In this video, we're going to review Chapter 2 of Real Numbers. Question 1, write the following numbers in scientific notation. Remember, scientific notation is a decimal between 1 and 10, and it's being multiplied by 10 raised to a power. So here, I have to have the decimal between 1 and 10, so I know it's going to be 6.67. And I know that because if I move this decimal place 1, 2, 3, 4, 5, I now have the decimal between 1 and 10, and it'd be times 10. And because I moved it to the right, and in standard form it's less than 1, I'm going to have a negative exponent. So this is negative 5. Next, 870.4. So if I move this so that the decimal is between 1 and 10, I'm going to move it 2 steps to the left. So this is going to be 8.704 times 10. And since I moved it 2 places to the left, this would be raised to the second power. And see, the decimal point is here. I move it 1, 2, 3, 4, 5, 6. So this is going to be 2.871 times 10, and I moved it 1, 2, 3, 4, 5, 6 places to the left, so it'd be times 10 to the 6th. Next, we're going to write each number in standard form. And standard form is what we had just an example in question 1. So here, if I have times 10 to the negative first, means I got to move it 1 place to the left. So if I move it decimal place 1 place to the left, I'm going to have 0.82. And just a reminder, if I have a negative exponent, my number in standard form is going to be less than 1. And my decimal is 0.82 is less than 1. Next, I need to move this 4 steps to the right. So that's going to be 1, 2, 3, 4. So now I'm going to have 50378. So that is 50,378. Next, 3 steps to the left. So that's 1, 2, 3, and then I can put zeros in that area. So we would have 0.003902. And that would be our number in standard form. Question 3, we want to multiply and write the answer in scientific notation. So here I have 2.7 and I want to multiply, so I'm going to multiply the decimals by the decimals. So I'm going to grab my calculator here, and we have 2.7, and we're going to multiply that by 3.4. That gives us 9.18. And then that's going to be times 10. And when I multiply like bases, I add the exponent. So 5 plus 3 is going to be 8. So our answer is 9.18 times 10 to the 8th. Next, I'm going to take 8.13 and multiply that by 1.1. So let's grab our calculator again. 8.13. And we're going to multiply that by 1.1. And that's going to give us 8.943. Just double check that, 943. That's going to be times 10. 4 plus a negative 7 is a negative 3. So 8.943 times 10 to the negative third. Question 4. Here we're going to divide and write the answers in scientific notation. So we're doing the same thing with the multiplication with this division here. We're going to take our decimals and we're going to divide them. So I'll grab our calculator again, and we have 5.6. We're going to divide that by 3.2. That's going to give us 1.75. And that's going to be times 10. And when we divide like bases, we subtract the exponents. So negative 7 minus 4 is a negative 11. And we just want to verify that our decimal is between 1 and 10, which 1.75 is. And if it wasn't, we would just have to adjust it by moving the decimal place to either to the left or to the right, and then adjust our exponent on our base of 10. Next, we have 4.8, and we're going to divide that by 3. So if I grab our calculator again, 4.8, divide that by 3, that's going to give us 1.6. That's going to be times 10. 2 minus a negative 12 is 14. So 1.6 times 10 to the 14th. Question 5, find the square root, the square or the square root of each number below. So 600 squared, if I square the 6, that gives me 36. And this is 600, so I would have to square the 600. So that means I'm doubling the number of zeros. So this will give us 360,000. Now I have to square 4/7. So if I have a fraction as the base, I have to square the numerator, which will be 16. Square the denominator, which will give us 49. So 16 over 49. Next, we're finding the square root of 196. That is a perfect square. That's going to give us 14. And then square root of 16 over 225 means I'm finding the square root of the numerator and the square root of the denominator. And the square root of 16 is 4. The square root of 225 is 15. So our answer would be 4/15. Question 6. We need to simplify these expressions in simplest radical form. And when we do this, we want to use the biggest square root that we can possibly find, our perfect square. So for this one, the biggest perfect square I can divide out of 1200 would be the square root of 400. And 400 times the square root of 3 gives me 1200. So the square root of 400 is 20. And then all I have left is the square root of 3. So our answer would be 20 square root of 3. Next, we have the square root of 338. So the biggest perfect square I can divide out of 338. Let's try 338. Let's divide it. If I divide that by 2, 2 is not a perfect square, but it tells me 169. 169 is a perfect square. So I have a square root of 169 times the square root of 2. Square root of 169 is 13. So it'd be 13 square root of 2. Moving on to our next couple questions. So question 7, we want to find the distance between each pair of numbers, round to the nearest hundredth if necessary. So we have 7 minus, so we're subtracting to find the difference between the two numbers, so how far apart they are. The square root of 14, let's put that on our calculator. So the square root of 14 gives us 3.7416. I'm going to round to the nearest hundredth first, so that would be 3.74. And 7 minus 3.74 would give us an answer of 3.26. So it's always going to be the biggest number minus the smallest number. Next, 5/8 and 3/4. I need common denominators. The common denominator of 4 and 8 would be 8. So if I multiply this by 2 and the numerator by 2, I now have 6/8 minus 5/8. And that's going to give us 1/8. So those 2 points are 1/8 apart. Next, find the midpoint between each pair of numbers. So to find the midpoint, you're going to add the two numbers and then divide by 2. So here we got 0.006 plus 0.007, and then we're going to divide that by 2. So that's 0.013. So 0.013 0.006, then we're going to add 0.007. That gave us 0.1013. Divide that by 2. We get 0.0065. Next, I'm going to take the bigger number, which is 2.68. We're going to add the negative, so 1.54. Then we're going to have to divide by 2. So we'll grab our calculator again. We got 2.68, and we're going to be adding a negative 1.54. Gives us 1.14. Divide that by 2, and that gives us 0.57. Question 9, Julia wants 1/3 of her 90 ceiling tiles replaced. The cost will be $2.69 per tile. What will be the total cost for the job? So 1/3 of 90, and then we're going to multiply that by 2.69. So we'll grab our calculator again. 90 divided by 3 is 30. And then we're going to multiply that by 2.69. That gives us an answer of $80.70. Question 10, we're going to use the Pythagorean theorem to find either the legs or the hypotenuse of the right triangle. So we have 7 squared plus b squared, and this is going to equal 25 squared. 7 squared is 49 plus b squared equals 625. Subtract 49 on both sides, and we have 625 minus 49 gives us an answer of 576. So b squared equals 576. To undo a square, you find the square root of both sides, and b is going to equal, I believe it's 24, but let's just verify that. If I find the square root of 576, that gives us 24. Next, we got 9 squared plus 12 squared has to equal c squared. So this is 81 plus 144. It's going to give us c squared. 81 plus 144 is going to give us 225 equaling c squared. To undo a square, we find the square root of both sides, and c is going to equal 15. Moving on to question 11. Here we need to name 2 integers each square root lies between. So the perfect square before 46 would be square root of 36, and the other side bigger than 46 would be 49. Now the square root of 36 is 6, square root of 49 is 7, so it's going to be between 6 and 7. Next, the perfect square before 27 is the square root of 25, and the perfect square after 27 is the square root of 36. So this will be between 5 and 6. Question 12, a 45, 45, 90 triangle has a leg with a length of 5 centimeters. Find the length of the hypotenuse of the triangle. So the length of one of the legs is 5, so A is going to be 5. Now if you look at the leg compared to the hypotenuse, here if the leg is A, the hypotenuse is A times the square root of 2. Since A is 5, the hypotenuse is going to be 5 square root of 2. And question 13, a 30, 60, 90 triangle has a hypotenuse with a length of 40 centimeters. Find the length of the long and the short legs. Now if we look at the base 30, 60, 90 triangle, we see that this is the short leg because it's always opposite the 30-degree angle. And if the short leg is x, the hypotenuse is twice that amount. Since we were told the hypotenuse of the triangle is 40, all we have to do is find half of that to find the short leg. So the short leg is going to be half of 40, which is 20 centimeters. And then if you look at the long leg, it's always opposite the 60-degree angle, and it's going to be your short leg times the square root of 3. So that means the long leg is going to be 20 square root of 3 centimeters. So that is a quick review on real numbers, focusing in on how to find radicals, how to use special right triangles, and simplifying expressions, and putting numbers in scientific notation.